Hello friends, so I've recently decided to focus again on projects involving electric motors, and one of the cheapest sources for relatively high-powered electric motors are used washing machines these days, and that is why I made several episodes revolving around that in the past. And in one of those videos I presented this salvaged motor here plus a cast iron transmission assembly, and that is actually very useful because it gives you the opportunity to have a rotating shaft attached to the motor which runs at much lower speed than the motor itself, but which gives you much more torque than the motor. And except from a few exceptions, that is actually what you need for almost all practical purposes. And that is why I want to show you in this video how you can actually get your hands on one of these assemblies yourself, and if you're lucky, for next to nothing. So what I have here is a roughly 20-year-old German-made Siemens brand washing machine, a front loader SR, almost all washing machines in Germany, and I've actually used this particular model here for a couple of years to wash my clothes. But it takes up a lot of space here and I don't need it anymore, so we'll tear it down today. And if you want to get your hands on one of these yourself, it's quite easy, at least in Germany, where you can just go on eBay Kleinanzeigen. That's similar to Craigslist. And there you just type in that you're looking for a Siemens washing machine, and you can also enter a price limit, like in this case 10 euros, and sooner or later you will find something. And that's because, well, people are moving all the time, these things are heavy, and at some point people just want to get rid of them. Unfortunately, not even all Siemens washing machines have the same build quality. This one is called Siemens Extra Klasse Champion, that means extra class champion, one of the more pricey models of back in the day. And here we can also take a look at the actual nameplate. So if you want to look for this particular model or something similar, you might be lucky. So let's start with the teardown then, and I will briefly say something about the smaller parts that we find inside, but the focus really is the retrieval of the motor assembly. Up here on the back side you can see two hinges or hooks holding the top cover or plate in place, and in order to open that up you have to unscrew one screw on the left and on the right up here. And after doing that you can take a look inside, and the first thing that we see here is the control board of the washing machine, and that holds a small switch mode power supply, a microcontroller, and then an array of triacs and also relays in order to switch all the loads of the washing machine, like the heating elements, the extrusion pump, and also the washing machine motor. But as I said in an earlier video, these boards are typically highly specialized for the purpose they were made for and are not easily repurposable, and I just recommend to you to either salvage parts from them or sell them as replacement parts online. If you're lucky, you can sell them for more than you paid for the entire washing machine. And other parts that can be salvaged from up here are, for example, this pressure switch here, the electromagnetic inlet valves. You energize the coil inside, and you can just do that directly by connecting them to the line voltage, and the valve will open, and since the water in the pipes is under pressure, it will then flow into the washing machine. Other parts are the power cord and this filter here, but also the housing of the washing powder dispenser that I took out earlier in the video. It is now also possible to disassemble and remove the front panel of the washing machine. You can, for example, also take out this transparent piece of plastic here, but in order to get it all off, you have to push out these little plastic pins that are held by these black metal springs from inside the enclosure. And this plastic part here seems to have gotten a facelift in 1997, so at least the design is about 20 years old. And after unscrewing the board sitting behind the front panel, we can see what can be salvaged from here: two rotary encoders, a couple of LEDs, and an LED 7-segment display. So nothing too valuable here really. So this is pretty much everything that you can salvage from the top side of the device. In order to reach the really interesting stuff like the motor assembly itself, we have to remove the back panel first. So what we have here is a round stainless steel enclosure holding the drum of the washing machine. Bolted to that, a heavy cast iron frame with a ball bearing in the middle, and in that ball bearing is a shaft, and mounted on that is an aluminium pulley, and that again is connected via a ribbed belt to a small pulley sitting on the rotor shaft of a large universal motor. And here you can see a bunch of clamps and stickers, and they are not part of the original equipment of this machine. I added them there a couple of months ago because I measured both the waveforms and the voltages across the field winding and the rotor winding of the universal motor in order to learn more about the exact mode of operation that was used here in order to control the motor. So the washing machine motor is held in place only by two bolts, one of which can be used to adjust the belt tension. Then we have two rather thick wires leading to these points here, and these are the power connections of the heating element inside the drum assembly. And these two thinner wires here, the blue and the brown one, lead to an NTC, a temperature sensor that is used to control the temperature of the water inside the drum assembly. This blue part down here is the float switch, and it's part of a safety mechanism that I will briefly address in a couple of minutes. So if you really wanted to only salvage the motor without the rest of the assembly, you could now try to just unscrew it. But it is very uncomfortable to do from this position and angle. But what I prefer doing is to put the machine on its side so that I can easily access that bolt with an ordinary size 13 wrench. And now I can easily pull out the motor out of the enclosure. And as you can see here, it's covered all over in this black dust. But that is not a sign of permanent damage of the motor of any kind. This is just a sign of wear of the motor brushes, and well, it's carbon dust from those graphite electrodes or brushes. And one day those brushes might have to be replaced, but in that case you can just order replacement parts online. But I don't just want to retrieve the motor itself, I also want to have that entire transmission or belt drive assembly. And in order to do that, I now first remove this aluminum pulley because it's rather frail and I don't want it to be damaged or bent in any way while I pull out those heavy parts. And because I want to avoid having to lift this heavy assembly off the ground at any point in time, I prefer to cut the enclosure here and bend this piece of sheet metal over so that I can pull it all out the backside without having to lift it. But there are still a couple of more things to be done before this entire assembly can be pulled out of the enclosure. There are these springs here, and they have to be unhinged or cut with an angle grinder. Then there are under the drum these shock absorbers that have to be unscrewed. And you have to open the door. You can do that by pulling on this rope here inside the enclosure. And then you would have either to unscrew properly or cut with a knife this door seal. In my case, I just cut it with a knife because I do not intend to reuse it. And there might be still some more cables and hoses attached to the drum that have to be pulled off as well. But then eventually you can take it all out and theoretically leave the enclosure behind you. So I'm now free to work on this entire assembly, but notice that I didn't put it on the ground directly, but that I'm using the old top cover of the wash machine to protect the little rod that is protruding from the other side, you know, where the large aluminum pulley would normally sit. I don't want it to be scraped or damaged in any way by the concrete floor. And speaking about concrete, this yoke that I'm removing here is also made, I guess, of some kind of very dense concrete. And you can find that in all kinds of makes and models of washing machines now. Back in the day, believe it or not, the German manufacturer Miele made these parts actually also from massive cast iron. And while Siemens always made very good washing machines, they spent a little less money making their machines absolutely rugged than Miele, and they already did that obviously around 20 years ago. And here we have a date code from the year 2000, so this thing is actually just around 17 years old. And in the next step, I now have to properly unscrew the ring that holds the door seal. Could have done that before, but it was kind of hard to reach. And after having taken off those clamps, I can now use a large screwdriver and a hammer to forcefully kind of get off this lid or front panel. And in the next intermediate step, I remove all the miscellaneous parts like the hoses and shock absorbers that are still somehow connected to the metal parts. And I do that because I have to separate the different kinds of waste or garbage here, because this will be scrapped and must be scrapped separately. And now I can finally remove the actual drum from the assembly. But I want to get that cast iron part loose. And that is connected to this outer enclosure here by 3 large bolts from the outside. And then there are 3 more bolts closer to the ball bearing. And well, I unscrew all of those until I finally can get that entire cast iron thing off. Still connected to the actual drum is the little rod though that belongs inside the bearing, and sitting on that rod is a piece of, I think, zinc die cast with these 3 arms, and we'll see how we get rid of that in just a minute. But for now I take out this entire thing, and the actual drum, that part made from stainless steel that remains, I know that you can do some DIY projects with that, but for what we're doing now it's not important and I'm putting it away. So we have now actually finally retrieved all the parts that we want, but in order not to brush over it completely, let's still take one more look into the enclosure of the washing machine, because there are some parts inside that I didn't address. Now I said that that blue switch on the floor is called the float switch, and that just means that when water gathers inside the enclosure because there is a leak somewhere, that switch is being activated, cutting off the power to the washing machine and especially to the inlet valve, so that your apartment won't be flooded when there is a leak. We still have a small pump in the corner, that's the lye or extrusion pump that pumps the old wastewater out of the machine after you're done washing. And then you still have an electromechanical door lock. But let's get back to the parts that we actually care about. Now before going inside, I'm using the compressor and the blowgun to get some of that carbon dust out of the motor and off of the other parts as well. So I've been talking about the advantages of having not just the motor but also the transmission in the beginning of the video. But one thing that is still very unpractical about these retrieved parts here is that there is this large, weirdly shaped, clunky die-cast part sitting on this rod, which kind of limits the applications that it could have. But I have now finally found a solution for that, so let me show you what I did here. Before doing this, especially protecting your eyes would really be advised, because some pieces of metal will probably fly through the air. So the basic idea here basically is to make some space so that I can use the angle grinder to cut alongside the steel rod that is encapsulated inside this cast material, and try to cut only so deep that I barely or possibly not even touch the steel, not to harm it. And I rotate this around and do this on all 3 sides, and then I cut with the angle grinder a triangle into the top or the tip of this part, connecting those 3 cuts. And then so what you have here now is a motor that you can basically get for free, plus a transmission, and attached to that transmission is just a simple stainless steel rod. You could, for example, drill a hole through that and then use a bolt or something like that to attach whatever you wanted to it, and I think that could be very useful. Another problem though that I've been talking about in one of my earlier videos was probably controlling these motors, for example having them run at constant speeds. But that only is a problem when these motors are run without a constant load and as universal motors, meaning that field winding and rotor are connected in series. But what I'm doing now here is connecting my lab power supply to the 2 windings separately and use these as separately excited DC motors, and that gives me pretty much perfect control. Also, using these motors as DC motors opens up the possibility to use them with batteries. Here, for example, the motor is running with only 20 volts across the rotor and around 1 volt across the field winding. And that means that even with low voltages, these motors can be used. Of course, if you want to have high power output, you would have to step up these voltages. Means that you would have to use a switching converter to do that. The next interesting thing. So then again, you could think about controlling these motors with Arduino and a much simpler circuit than using my self-designed lab power supply here, which is maybe a little overkill for this whole thing here and is not really reproducible by the viewers. So I could think again about building something like that. And then I've been thinking about trying to use this for some kind of small vehicle, maybe an electric cargo bike or something of the sorts. It wouldn't have to be perfect, just a proof of concept. But if you like any of these ideas, then let me know it. And if you can spare a buck or two, then visit patreon.com/tpai and help me out a little bit with my future ideas here. So I hope that you like this and to see you soon with a video that will somehow revolve around this topic.